collaborative way. So today we have our amazing guest from IIT Gandhinagar. So the team of students are from IIT Gandhinagar, and they have joined us today. And I am sure most of you would have seen a recent video which was really viral, where the students out of IIT Gandhinagar have built their very own fully autonomous vehicle, which can be used in their campus, and it is a revolution towards the next step of self-driving vehicle. So their work in this particular field is cutting edge, and they have some fantastic insights to share. So it's my privilege to welcome the team today. Welcome everyone from IIT Gandhinagar. Yes. So firstly, I'll ask Rishikesh to introduce us to the team and also take us through some insights into how did they come to know about this particular topic and why did they choose to build a project in the autonomous vehicle. So, Rishikesh, over to you.
So, my audible. I just want to confirm that the audio source is okay. Hello.
Yes, you are
Okay.
audible, Rishikesh. Yeah.
So, should I share the slides now?
Yes, yeah.
So, showing that's been disabled for me, and also my camera is not working right now. So, could you please?
No issues. Let me share the PPTs. Just give me a minute.
Okay. Okay.
Yes, Rishikesh. Yeah.
Okay. So, hi guys. Good morning. It's really exciting to see such a wide audience in front of. So, let me just quickly go over who our team members are. So, firstly, we have Abhirajar Mohan from discipline of mechanical engineering. Alongside him, we have Anawat Pandya, Kush Patel, and Sania Patradhan, along Ashutosh Goyal and Ravi Dharaja, all from mechanical engineering with minors in robotics. We are also joined by Rajesh Kumar from chemical engineering background with minors in robotics. Additionally, we have Rahul Arpai and myself, Rishikesh, from mechanical engineering with minors in computer science. Last but not least, we have an interdisciplinary person, Arvind Krishna, who is a dual major in both computer science and mechanical engineering. In our group, there are individuals from several domains of interest, which includes robotics, image processing, machine learning, hardware acceleration projects. There are some of them. So these are just a few examples of projects our team members have taken, and our most significant project to date is indeed the autonomous vehicle project. So that's all from the introduction.
Okay, great. I think we have a wonderful team assembled here who is having all the skills. So, Rishikesh, can you also tell us, how did you, come up with an idea regarding autonomous vehicle and what made you guys to choose this as a, project topic?
So I think Tanya can do
Mm.
that better than me. So
Okay. Yes,
Hi.
Sanya. Yes.
Hi everyone. So as we've already been introduced, we were a group of final year BTech students wanting to put our whatever that we have learned till now into some practical use. And simultaneously, we had a problem on campus that in the scorching heat of Gujarat, we getting up from our hostels and going to the classes every day in the morning became a little hectic. So our professor Harish sir, he came up with an idea of creating an autonomous campus shuttle for the use on campus. So next slide, please.
Yeah.
One more. So it start like we couldn't directly get an electric vehicle. So it started out as a hobby project on a student-made go-kart. So the vehicle that you can see in on the PPT uh, is a student-made go-kart made by some of our seniors. So we made some modifications, worked in the machine shop, worked on the steering mechanism a little, added some actuators, and then made this vehicle autonomous. So in the next semester, one more slide. we got this vehicle, which is an electric vehicle manufactured by Savvy Electric Vehicles. And then we decided to make this autonomous, which is completely driverless. And we'll be speaking more about it today. Before that, let's look at a video about our current progress.
Yes, most of the kids are eagerly waiting to see this. Wow, that's really amazing. So, kids, did you all like it? Did you enjoy it? Yes, yes. I think
So,
it was yes, yes, and
so looking at the video, like you might have already realized what autonomous vehicles are. They are vehicles that do not need a driver to operate them, and they can make their own decisions about how much to turn and whether to stop or to go on the road. So that is what we have created, and we'll be talking more about it.
yes, I think already questions have started to come, like what kind of sensors you have used and what is the different systems that are in place. So I think it's now time for us to get into a little bit of details. So team, if you can break down the technology behind autonomous vehicle in simple terms, so that kids can understand. They will also be able to understand the technology behind it. So, if you can, walk us through the multiple technologies and systems that is implemented in the autonomous vehicle, that would be really helpful. So, I think Arvind, should we change the slide?
Yeah, please.
Hmm.
Hi all, I'm Arvind, and then I'll be getting into the different aspects of how we, created the vehicle. So, as a part of any autonomous project or maybe like any robotics projects in general, it is very important to identify the different subsystems that are like involved in the entire project. So I'll tell you, for the first entire month, we spent like the entire month in ideating, identifying the subsystems, working on the different subsystems in theory, like creating the code, writing the code, and everything. And after that only, like we got a vehicle, and then we started working on the vehicle. So about the different subsystems involved, we have lane detection, steering mechanism, object detection module, accelerator or the brake mechanism, controllers integration, and system integration. So the system integration also includes the power management and everything. So we'll be going through all these different subsystems like in detail. So like in a way which all of you can understand. So yeah, so like in the first week, we were given the task to create a concept map. So can we go on to the next slide? Yeah, so this is a basic concept map which gives an idea of like how our entire vehicle works. So one thing which is to be noted is that can we go to the previous slide, please? Yeah. So one thing to be noted is that the vehicle will run only on a pre-decided road, and then we are following only class 2 automation. And then the when our vehicle sees an obstacle, it just stops, and then when the obstacle moves away, it moves. The like our cart will again like start moving. So it doesn't avoid the obstacle and then like move around the obstacle. And then third important point is that we are not using a GPS for navigation. So as you can see in the image, we have different systems like the brake and speed subsystem, the steering subsystem, the obstacle detection, the lane detection, and also we have also provided a manual override just in case there's an emergency situation where we need to like control the entire system by ourselves. So there are two different types of manual override. One is using an RC controller, which all of us have seen from our childhood, which we use to control our RC small cars. So we have implemented that also, so that we can directly control the entire cart with an RC controller. And also, like we can physically override it. We can get into the vehicle and start riding it. So I think that's about like how the vehicle works in general.
Okay, got it. So, can we also know like what are the step-by-step process, and how did we do it, so that kids can maybe get more details about all the different aspects that we got to know here. I think some more information in this would be more helpful. Yeah.
Yeah. So I think one of my team members will explain how we
Mm.
implemented lane detection.
Right. Yes.
Sure. So, hi guys, I am Anawat Pandya.
Mm.
So I'll explain you what is lane detection and steering mechanism and how do they work. I hope you are excited. Yeah, so first of all, let's understand what does lane detection mean. So let's say you have a lane that the car needs to follow, and you have to follow it through an RGB camera. So red, green, blue camera feed. You have to detect where are the lanes, and then you have to tell the car that what is the coordinate of the lane that it needs to follow. So we have many approaches in today's world. Some are very complex that use machine learning algorithms, and some are traditional computer vision algorithms. So we have used one such traditional computer vision algorithm that has several steps, as you can see here. So what we get is, first we get a raw camera feed, then we do a canny edge detection process, then we do a region of interest marking, then we do a Huff line transform, and then finally we average out the lines. So this might seem overwhelming at looking at the name. So let's go one step at a process by viewing what each process does to the image. Can we move on to the next slide? Yeah, so as you can see on the left hand side, we have a raw camera feed out of 6 images. The top left is what we get through the camera. Then we apply a canny edge detection computer vision algorithm. All processing is done in Python. So here we use OpenCV library for it. In canny edge detection, as you can see, all the edges are highlighted in the image, and the rest all is highlighted in dark purple or black color. After the edge detection, we have region of interest. So we only mark the region of which we are concerned. So here in this case, we have marked a trapezium, or in some cases we mark a triangle in which we expect the lane to be in most of the times. Uh, the next part after this, we mark out straight lines through a Huff line transform algorithm. So basically, it marks a straight line in the image according to the parameters given by us. Parameters such as what should be the length of the line, how close the lines have to be with each other. This all is done by the Huff line transform algorithm. After that, we average out the lines, but here we add one of the filters. So is my cursor visible here?
Not really. So if you can,
Can you take it to the horizontal red line in the left hand side of the image?
yeah.
So as you can see, these horizontal lines are of no use for us because the lane lines are expected to be triangular in the shape. So we filter out those, we exclude those lines to get averaged out. We only consider some angle of lines that are in the range of the lane. And finally, when we average out, we get two perfect lines as in the fifth image. And then we find the center line of the detection. So as seen in the sixth image. Now, what we do with the center line is we find out the center of the center line. It should be marked as a small red dot. You will be also be seeing a pink dot. What does pink dot mean? So pink dot is the fixed camera frame center. So it will always be at a particular coordinate on the frame. It will not change. What will change is the center of the center line that is marked. And just remember a fact for now. I will explain it later in the slides. Uh, we are concerned with the error that we get between the two dots. So the distance on the frame between the red dot and the pink dot. This is what we are concerned with. So our entire cart will move on that feedback, right? So let's move on to the next step. So as you can see, this is a video implementing the lane detection algorithm. So the blue dot, maybe you can come back to the slide again.
Yeah, okay.
Yeah. So as you can see, the two lane lines are getting detected and the region between it is getting detected. And we have a center line that is getting detected. The blue dot of the center is the detected center and the pink dot is the fixed frame. What we are concerned is with the error between those two. Maybe you can move to the next slide. Yeah, so now something hands-on. So we have a steering mechanism. As you can see, we have a chain attached to a motor on the right-hand side and the steering axle on the left-hand side. So when the motor rotates, it rotates the steering axle. We have some gear ratio between two, and the chain mechanism allows both gear to move in accordance. So what we will do is we'll power the motor through a power supply, and then we will send the command PWM signal to the motor. That PWM signal will be sent through by an Arduino board. I hope all of you have used one such board, microcontroller. And how does Arduino know what command to send at every instant? So we have a Python code in loop. When we run a Python code, what it does it captures the feed from the camera and then do the processing as I mentioned earlier. It applies the 6 steps of processing and get the error distance. Then we have a code block called as PID control. What does that do? It converts that error and applies some mathematical functions, complex mathematical function, and convert it into a PWM signal. You can understand it easily as a voltage signal. So it ranges from 0 to 255 and it has two direction, either clockwise or anti-clockwise, plus or minus. So the algorithm that I discussed previously, along with the code block, PID control, decides whether to send a plus signal to the motor or a minus signal to the motor. Hereby saying that whether the motor should rotate anti-clockwise or clockwise and with how much voltage. So like how much torque you can understand, having a value from 0 to 255. I guess we should see this in implementation. Next slide. So this is the same video that we showed earlier, but I would like to specifically focus on some part of it. Maybe can you move to 40 seconds mark? Yeah, so as you can see here, the lane detection is happening on the left-hand side, and on the right-hand side, the steering wheel is moving on its own. Can you pause the video for a second? So as you saw earlier, the lane detection was happening and the steering was rotating. So all the process was happening in real time that I explained right now. What you can see now on the video frame is that we have another mode, which is joystick enabled mode. So in some cases, if there is a failure in detection of the lane, or if there is a failure in moving the motor in the right time, we can stop it. We can stop the override by manually controlling through a joystick. So we have a joystick that you can see I hold in my hand. For a better look, I have it with me. You can focus on my frame. So this is a joystick. It has multiple axes. It has the throttle axis and it has the rudder axis. Basically, I am using a rudder axis, and when I click the red button, it changes to a joystick mode immediately. So now you may play the video. As you can see, the computer is taking the input of my joystick, and the steering wheel is rotating based on my axis input. So this is all about the lane detection and steering mechanism autonomy, along with a joystick manual override feature. Thank you so much.
Great. I think, kids must have been very excited to hear that you have used Arduino and Python, which most of them will also be using. So great, great. Yes. So what about the other systems in place, right? How do we do it in detail? I think most of the questions were around the sensors, like, what kind of sensors are used, right? So if we can answer to that question and take us through the further topics, it would be good.
Yes, sir. So I'll be going through the obstacle detection. So another part of the autonomous vehicle is the braking and the acceleration system. So we also have to consider any obstacles that are coming into the path right now. So at this point, our vehicle, when it sees an obstacle, it just stops and it doesn't avoid the vehicle and move around the vehicle. So I'll just go through what all we have implemented to get these features. Could you move to the next slide? Yeah, so initially, before even implementing the autonomous system, we made the acceleration and the brake control using the RC control. So this is a video showing how we control the acceleration and brake using remote control. So you can see that I've toggled the switch and the vehicle stops, and when I release it, the vehicle moves back. The driver here is just steering the vehicle. He is not touching the acceleration brake pedal. So can you move to the next slide? Yeah. So this is one of the important sensor or camera that we have used for this obstacle detection. So this is the Intel RealSense camera. So this is a RGB-D camera. So this has RGB sensor that we all know what it is, an IR sensor and a depth camera. So a depth camera is what we have used in this obstacle detection. So it provides us a depth map of the surrounding. Can you move to the next slide? Yeah. So here you can see that's one of my friend here, and you can see the corresponding depth map here. So the blue part there is the closest region, and we can see the color fading to from blue to green to red. So the red areas are the faraway regions, and the blue ones are the closer ones. So this feedback provides us at how much depth each pixel of the camera frame is. We move to next slide. Yeah. So obstacle detection. So for obstacle detection, we have used an implement code known as YOLO V7. So YOLO V7 has several classes to detect several objects such as animals, humans, plants, vehicles, etc. So here you can see that a few images of the horse and cats are being detected. And also on the left side, you can see that a color map is there. So the color map provides at how much distance from the camera that the object is. So the blue part is the closer ones, and as it gets far away, it turns from the green to red, etc. So can you move to the next one? Yeah. So we also have to keep in mind that we do not detect all obstacles that are in the camera frame. For example, for example, people moving in the left lane. So we only need to consider the ones that are coming into our lane on which the vehicle is moving. So for that, we have used the same lane detection code that Anavarth explained. And you can see the mask that we have created, the green one on the right image. So this mask will detect if any object will come into the frame, into the lane, and the vehicle will stop respectively. Can you move to the next slide? Yeah, so this is a video of how we have implemented it. So you can see the live mask on the left side and the raw feed here. So you can see the detected person here. Can you play the video? So you can see as the person moves into the lane and it's being covered up in the green area, the vehicle stops. And as the person moves away, the vehicle starts moving back. Can you go to next slide? Yeah, so this is, we just go through the video again. So this is the part of the obstacle detection. So you can see here, this is being live implemented. You can see that a human object is being standing in the road and the vehicle has stopped. So here we have implemented it at 5 meters. We can change the distance. So whichever obstacle comes within 5 meters in front of the vehicle will stop. And it has started to move when the obstacle has gone away from the lane. Also, we have only implemented this obstacle detection to detect anything in front of the vehicle, not on the sides. So that's how the obstacle detection works.
Okay, great. I think, that is, some insightful information that we have received. And I think kids have a lot of questions now. So we can maybe take few of the questions and then we can continue further. So, the lot of questions were around sensors. So, can you tell me, like, what are all the sensors we used in this? Is just the intense the camera sensor, or do we have other sensors in the vehicle?
Yeah, so I'll answer that. So for both the lane detection and the obstacle detection, we have used only cameras. One RGB camera, the normal webcam we use, that's for the lane detection, and the other one is the real sense camera of the obstacle detection.
Okay, got it.
So we
And
are working the whole autonomous system based on vision only, nothing, not IR sensors.
okay, great. So kids, what they have used is an advanced version, and but still the principle applies the same. And Mayank over here asked one question. Can it detect any potholes or any kind of obstacles that are in the ground, not a real person?
So yeah, I'll tell that again. So we have used a YOLO model here. So what YOLO model has is it has pre-trained classes. So there are several classes, like I said, the humans, vehicles, plants, animals, etc. But right now it doesn't have plot holes. But in case we need plot holes, we'll have to train the machine learning model again to detect plot holes.
Okay, got it. And so any kind of further implementation can be done through slight modifications to the algorithm. That's right. Yes.
Absolutely.
Okay. Okay, great, great. By seeing those videos and by seeing all the systems, I believe, it is quite a complicated process to get all the material sourced and, do it. And that too, when you guys are, already in college, I'm sure, being in IIT and completing your subjects and doing assignments will only take a lot of time. But in spite of that, you have done a wonderful job and you have made something very innovative. So when it comes to this, right? So can you walk us through some of the challenges that your team has faced when you are designing it or manufacturing it in IIT, and how was the overall experience? Finishing your first product. So I think that is something very insightful to hear. So can we know
I,
about
I
some insights? Yeah.
yeah, I think I can take on that question along with the discussing the design and manufacturing process.
Yeah.
So
Yeah.
hi everyone, I'm Abhirat. The designing and manufacturing process as well as the ideation of the various components of the vehicle was like complex. It was not a single step in itself. So like a lot of ideation, my fellow teammate Arvind said, like we had a month of pre-planning to like what to implement, how to implement it. So like lot of ideas, lot of brainstorming, a lot of sessions itself, and like lot of uh, hurdles that we had to go through. And like we had like many ideas, but they were like the best, but they were like impractical. So like with the limited resources that we had, and like as well as time, the time itself. So like we had to like make sure that we are like at a sweet spot. So like implementing everything that is working, that is reliable, as well as what we could achieve in the short period of time. So the key parts, like let us go through some of the alterations that we did to the vehicle itself. So like one of the key things that we had in mind was like whatever we are doing to the vehicle should not like affect it completely. So like it should still be traveled by a human. So whatever we are doing is temporary. So like the systems that we are adding onto a vehicle, we could like remove it and it's still working as a golf cart. So that was one of the key things that we had in mind. So keeping this in mind, we had to like add a lot of systems. So like one of the other system was like camera mount. So could you take back to the previous slide? Previous slide. One more.
Yeah. Once.
Yeah, here you can see us in the left picture. You could see us building a structure onto the go kart. So the go kart was one we worked in previous semester. So like the thing was like we had to like make sure the cameras were at a certain height, and there was not the vehicle vibrations and all would not uh, make it to the camera. So we had to make such a structure. So, but when it came to the golf cart was electric, and it was like it had much complex suspensions, and also like we could do with a simple mount. So like the that task came through very easy. So like from one to another, and but the other actuations like steering mechanism, acceleration, and braking were like complex, and like it did have a lot of addition. So I can talk you through the how we did the acceleration mechanism. So acceleration for the electric golf cart was electric. So like it didn't need any mechanical actuation as such. So what they did have was an accelerator pedal that like it controlled the voltage. So what we did was like uh, add a secondary circuit. So basically we are giving an input, and if you have to flip a switch, the secondary circuit which we are giving the input through would be the one controlling the vehicle. So with controlling the switch, we could like determine if the accelerator pedal is working or not, or the command that we are giving is working. So that's how we figured out how to use the acceleration mechanism. This was not our first choice. Our first choice was mechanical linkages, but this was the one that worked out in the end. And could you move on to the next slide, please? And and similarly for the steering mechanism and the braking mechanism, steering mechanism, as my fellow teammate Anavat has been talking about, we used a chain and sprocket mechanism. So we had a motor, and so the motor mount was fixed to the frame, but again, this was removable in nature. And for the braking as well, we had a uh, motor with winch-like mechanism, so like it pulled along the brake cable. So that's how it worked. And again, I should again like emphasis on put emphasis on this. Like it was not a first choice. A first choice was another ideas, but this was the most practical uh, as well as the feasible idea. And the other thing was like we needed a computer on the system because like you can see the all of this is computationally hectic heavy task. So we needed to have a computer on the golf cart as well as a power source. So what we used was like we kept a PC in the footwell of the passenger side, in the front actually. This the picture that we have is not the final one. The PC was kept in the footwell actually, and the inverter was kept behind actually. So we had seats for the passenger itself. So again, uh, such ideations and such brainstorming was needed. Like having such a like a power source that can power a whole entire PC on board was challenging as well itself. So mm, a lot of tinkering, a lot of ideation, a lot of brainstorming was needed, and like we had to keep an open mind for this. Like we couldn't fixate on yes, we will do this, but it in the end it wouldn't work out. So we had to like keep an open, like maybe like backup, like a lot of backup ideas, a lot of like chatting with like a lot of people actually. So like even the a lot of people like who are not in our group itself contributed to like in this project, and like they did help us to like brainstorm and like give us ideas. You could do this, you could do this, and those key things were like they made a huge impact in the project itself. So like keep an open mind. The solution could be anything. It could be a simple task, it could be a heavy task. Like you cannot predict what the solution can be. So that's the whole thing about like such a project with design and manufacturing for such a complex project. So that's it from me.
Yes, I think Abraj, I can understand, the way you explained, you must have faced a lot of problems and issues down the line. And I can understand, how you and your team have gone through it. And there's one important point, kids, you have to note here that what Abhiraj said, no matter what the challenges, if you keep your mind open and if you keep seeking for ideas, I'm sure, you will be arriving at a solution because every problem can be solved. And their team, out of the frugal resources what were available to them and with the time what they had all the help, and they took all the resources with both of their hands, and they have done something insightful. So that is what we at Plato Labs also want to do, where we don't want our children to think that innovation can be done only through industry grade components, but innovation can be done through any of the materials that are available at house itself, right? It's just that you have to think about the idea, and if you think about it and keep your mind open, I'm sure you will be able to come up with some way to make it work. So that is wonderful information, team. I think this will definitely inspire our kids to even go further and progress in a direction where they want to bring their ideas to life. That's wonderful to hear. And but we have few of the questions coming in YouTube where kids were asking, so how different is autonomous vehicle with the normal vehicles, right? And how do we know that these autonomous vehicles are the best, right? So a team, if you can help us with some information about the basic differences between the vehicles, that would give some insights to the children as well.
Yeah, so
Mm,
I'll answer that question.
mm,
So, hello everyone. Myself is Push Patel. So, let's talk about the basic difference between the autonomous vehicle and the regular vehicle that we used to drive, right? So, after hearing all this information, like all the subsystem, lane detection, obstacle detection, brake and acceleration system, now we are capable to distinguish between the autonomous and the regular vehicle. So, let's take a look on the few features based on which you can differentiate the two vehicles. So first of all, definitely it's about the driver. So in the regular vehicle, we need a driver, but in the autonomous vehicle, the vehicle can drive autonomously. The second and the third feature is slightly overlapping, like the automatic control and the smart decision. So what happened in the regular vehicle? So the person is driving the vehicle, right? So based on that person, he observed the outer environment and he make the decision like when should we apply the brake, when should we apply the accelerator. That's all things. So that's all included in the manual control by the human perspective. But in the autonomous side, we have the automatic control with the smart decisions. Like we have implemented in our vehicle the lane detection system, also the obstacle detection. So those are the smart decision. On that decision, we have made the control on the accelerator and the braking system. Like if there is an obstacle coming in the vehicle in the main path, the brake will automatically apply. Then when the brake release, the acceleration will be automatically applied based on the given range of the speed as well as the range of the obstacle. So the last point is about the traditional engine in the regular vehicle. So right now we have all type of vehicle with which uses the petroleum-based fuel like petrol, diesel, gasoline, etc. But in the autonomous vehicle, the main part would be they use the advanced technology in terms of like they use the electrical system, also the hybrid engine. So in our vehicle, we have given the golf cart, which is the electrical. So there is no traditional engine mechanism in the similar to the regular vehicle. So yeah, that's these are the basic features that we can use to differentiate the autonomous and the regular vehicle. So yeah, can we go to the next slide?
Yes.
So now the question comes in our mind, like what's the future of the autonomous vehicle, right? So these are the major points, but not these are not only points that we can define the future of the autonomous vehicle. Like already I said, in traditional vehicle we use the traditional engine mechanism, but in autonomous vehicle there are electrical engine. But also there is a eco-friendly on which we can go to the sustainable environment. So right now, a lot of research is going on based on the hydrogen fuel, right? So in the traditional engine, what happened? The combustion gas would be the carbon dioxide, which affect the our environment. But in the hydrogen fuel, what happened? The combustion gas would be the water, so or the vapor of the water. So it will be more sustainable step towards the environment. Also there is a super smart car, also the connected and the communication part. So right now there is a lot of progress in the artificial intelligence. So in future, so people can implement the artificial intelligence, integrate the artificial intelligence in the current system, so again the car itself adopt the outside environment apart from the census data based on the the training module and all things. So based on artificial intelligence, we can proceed with the further advancement. Also, there are more safe car ride. Also, the future would be so all people are not same, right? So the car would be based on the some disabled people who can not who cannot walk or who cannot see. So based on that person, the advancement would be happen in the future. So, yeah, these are the possible future for the autonomous vehicle.
Yes, I think definitely that is going to be the future because already we are seeing a lot of innovation in this
Right.
space, and every device and every appliance that we were using has become smarter. And I'm sure a lot of young innovative minds like your team will definitely take our world to the next level. And I think it's going to be more safer for us, and let's build a great nation together. Yes. So I think kids, you must have enjoyed the insights that given by the team from IIT Gandhinagar. I have enjoyed this session because there were some truly inspiring insights that they have given out of the autonomous vehicle that they have built. So I'm sure kids, you also have got useful information on the autonomous vehicles and have basic idea on how they work and how you can also get into these kind of technologies, right? So team, so it was truly inspiring to see that your team has stepped up in during the college itself and have done something innovative like this. So can you give some advice or some information to the kids young minds who have gathered here, which will also help them to become the future innovators. So if the question is that can you tell something for the kids? I
I
think,
think I can take up that question.
yeah, Arvind.
The something what I would suggest is like you should, like try to explore everything that's around you, even if it's from if it's just a small project, like which is like just measuring the humidity in the soil. Like I think you might have seen it online. So start with this, start with the basics, do different kind of projects, like explore different projects, and don't feel like whatever you're doing is it doesn't add up to something. Even like throughout the presentation, you might have noticed that like we have used very basic controllers like Arduinos and cameras and everything. Which and this project is not something which is not doable by you guys. You can also do this. Like the only thing is you have to like work towards it. Like like start with small projects and it will be done.
Yes, I think start small and start now is the
Yeah, yeah.
option, right?
Uh,
So
I
I
guess I
think
would
that
like to add one thing to Arvind's point.
yes,
What we realized while doing this project was that core mathematics fundamentals are used a lot. So from the day one, you should have grip on each and every mathematical fundamental. So all these algorithms that we used are a result of core mathematical research and understanding. So that should one of be the core strength of a robot assist.
right. So having strength in mathematics, I think robotics is a multidisciplinary field. So I'm sure each one of you have contributed your own expertise into it. So kids, no matter what you are studying, if you can understand it properly and know from the basics of what you are learning, I'm sure it will be useful. And team, I have another question. So I know if kids want to get into these kind of industry like autonomous vehicles or self-driving cars. So, what do you think, they should learn, or what do you think they should focus on, so that, they can also go ahead and work in these kind of technologies in future? Um, Arvind, can you answer that, or anyone from the team?
Yeah. So, as you might already know, robotics or autonomous vehicles need skills from mechanical engineering, electrical engineering, and computer science. So, if you go and do any of those and still have an interest in autonomous vehicles, you can still build more expertise in that particular field, and then later move on to autonomous vehicles.
Okay, great. So our kids, so the path is clear. You need to know about electronics, you need to know about coding, and you need to know about mathematics as well. And as you do more of this, as you know more of this and become better at this, you can get into such innovative technology like autonomous vehicles. And I'm sure, a lot of kids here are already on this path, and this is what, you can do. So we at Plato Labs also do the same thing, and that's a fantastic advice from the team as well, where we want children to focus on practical learning and think about innovation during the school days itself. So we'll be very happy if kids right now can replicate something like this during their school itself. So that would be a next step towards what we are building here today. So on behalf of all the kids and parents and the teachers who joined here, so I heartfully thank the team from IIT Gandhinagar. I'm sure they're very busy with their work and studies, but still they have taken their time, and everyone have joined because they are very much excited to see that kids are interested in knowing this. And I'm sure they were when they were answering the questions from the kids, they felt that these kids are good, right? So they are able to ask good questions and they are able to understand what they are saying. So that is nice to see. And so we will take up few questions now before we conclude, so that we will not leave any questions left behind. So so a few kids were asking, what is the future? Like how do you guys plan to take it forward from this? So anyone from the team can answer, that would be great.
Yeah, I think I can answer that.
Mm,
So, like for if we say for next semester, we have actually planned on implementing other algorithms like
mm,
obstacle avoidance. Currently,
mm,
we mentioned that like the cart only stops on seeing an obstacle.
Mm.
So the next part of it would be like, yeah, obstacle avoidance. It will move around the object and then proceed. And then the second one, like for now, we have a predefined track on it, on which the cart moves. So next one would be like integrating GPS with it so that like we can provide like a particular path and then it can follow that. So these are like few things that we are planning.
Okay, okay, got it. So Sid here asked, does it mean that you will make more of these vehicles in your campus, for your campus?
No, actually, we are like planning to make this better and then like integrate as many like different features as possible, and then maybe like as you said, we can make more of this.
Okay, okay, got it. And there were a few questions. So we have questions from uh, Jashwant and Takshvi, etc., who asked, any tips on how to get started with OpenCV and how do they start?
I
Maybe.
think Anawat can answer this.
So OpenCV is a library for computer vision in Python. So it is it can be as simple as it seems, and it can also have a complex part to learn about. So first, I would suggest that you build smaller projects like hand recognition or simple color detection projects, small projects that are available on internet. Get a good grip on it, then try to understand what is happening behind the algorithm. So it will have some predefined functions. Try to understand on your own and through internet resources that what does each and every function do. So you will get to know that basically it is just mathematical algorithms in play, matrix multiplications and all. And then you can come to such complex applications like lane detection and all that are having a hefty part of step-by-step processes. So that is where you can start with. This is what I also did in my college days to start with computer vision algorithms.
Okay,
Also, one thing to add it in that the best platform to learn this all things like the YouTube. Along with side, there are some courses on the internet, like on the Coursera and everything. But YouTube is the best thing because some of the creators have specifically made for the particular topic, like OpenCV, or for the particular library. They have made the whole playlist, like from the scratch to the advanced part. So that would be the best thing to learn and to start with. Also, there are some projects. So, yeah.
yes, I think we are in the era where informations are readily available, and it's just that we have to reach out to them and see what we can do, and practice children. There is no other way than doing it on your own. So if you want to learn something, please do it hands-on, right? Take up some small project, small topic, and try to do it on your own and see how that works. And that is the best way to learn something. And Takshvi here have asked, what do you mean by light masking? So if anyone can answer that.
Yeah, maybe I can take the question. So, I guess I may not have been clear. It is not light masking, it is region of interest masking and lane detection. So, region of interest masking is one of the processes used in the lane detection algorithm, which masks out the desired part from the image, and we will now after process only on that region. So we will avoid excessive like processing of the image in the other parts of the image that are not desired to have lane in it. So that is what region of masking is. Region of interest masking, to be precise.
Okay, okay, got it. And some of the kids here were saying that your team should definitely go to Shark Tank. So will it be possible? Can we see you guys soon in Shark Tank?
Yeah, I think possibly like after, as I said, adding on more features, and then yeah, we can possible.
Right. So we also wish that you guys go and make something very useful, and definitely you will be succeeding in the future as well, right? And there's one question, common question that I'm seeing in both Zoom and YouTube is that while we talked about all the pros, right? So what are some of the disadvantages or cons? in autonomous vehicles. If anyone can throw insights on that, it would be really great.
So, of course, there are many safety risks when we talk about autonomous vehicles because in a fully autonomous vehicle, there won't be anyone to look if there are anything's happening that are not planned. Like suddenly a person comes in front of the vehicle very close. So that's why to tackle these issues, we had decided to start our project in a highly controlled environment where we know the lane and we've already informed people to not come in the lane, and we have many stop signs placed there. But if we are taking this forward to public roads, of course there might be safety risks, and thus we need to do many modifications in the car before we get them on public roads.
Right. I think that answers it. We were testing out in the control environment, but when it goes to actual implementation, we need to be considering all the other options, and especially I think launching something this should be phased, where we will do it in multiple stages, and then we take it to the common public. So I think it will take some time, but I'm sure a lot of young minds like your team will definitely push this further and accelerate it in such a way that it can be implemented in real life very soon. And like the kids over there who are watching that they will be seeing you guys in Shark Tank soon. So we at Plato Labs also wish you all the very best. So you have done a wonderful job, and you're already on your way to becoming the future innovator. And it's truly inspiring to see that you have taken the step to motivate the kids also into this direction. So thank you, team. Thank you, everyone. So for joining and helping us with this information. I'm sure this must have inspired a lot of kids to progress in this direction. So everyone, it's our privilege to bring you an interesting topic today, and I'm sure all of you enjoyed today. So do subscribe to our channel, and you can see more innovative videos like this. And we'll be back again with another Plato talk with an amazing guest who has worked in an innovative technology. So until then, it is bye bye from my side, and take care. Have a great weekend, and all the very best, team. Take care. Bye bye.